So now we're going to solve question number 5, which states that which asks us to prove that the Laplace transform of the derivative of the function f of t is equal to the Laplace transform of the function f of t multiplied with s and minus f of 0. So that's what we're going to do. This is the question that we've been given, right? And so this is the question, and we're asked to prove this. And what we have to take first, what we have to explain first, is that the Laplace transform of any function, let's say f, is equal to f in terms of t, is equal to the integral of from 0 to infinity e to the power negative st multiplied with f of t, which is the function here, multiplied with dt. So this is what a Laplace transform is, right? And of course we have the constraint that s is greater than 0. So when we take into consideration that we are using a derivative here, we have to say that it's f dash, right? And we have f dash t instead of f of t. So we already know what the bipart rule suggests. The bipart rule says that if there are two variables uv, if we have to integrate both of them, then we choose, let's say u, the integral can be this minus u multiplied by the integral of v minus u dash, and here we have the embedded integral of v. So the integral of v, and then we'll integrate it again. This is what uv is, but we have f dash here, which means we have f dash here, right? So instead we say this is uv dash. Let's say u is e to the power minus st and v is f f of t, right? So u dash, I mean, let's just write it all out here. U dash will be minus s, right? We have the coefficient here, minus s multiplied by e to the power minus st. V dash will be f dash t. So this will be u multiplied with v minus u dash multiplied with v, right? Because integral of v dash will be v. So we've got that pegged down, and this, thus we can write it as e to the power minus st multiplied with ft, right? The limits minus, because that's what this suggests, minus minus s e to the power minus st, is also from 0 to infinity, multiplied with f of t dt. We have that. To simplify this further, we'll get, right, what we can do is we can just take this ft and we can say that this is what we have, again from infinity to 0. And then we can say that if you look carefully, right, if you look carefully, and if we were to separate this from the negative s part, which the negative sign goes here and multiplies with the other negative sign, and we get a double negation, which means positive. And so we find that this e to the power minus st multiplied with ft multiplied with dt is exactly what we have here with the same limits, right? So we can naturally assume that this is the Laplace transform of the function s, right? And we already see that the desired proof is already emerging from this answer. We have this here. All we need to do is simplify this further. So let us say that f at infinity, so the time is infinity, let's say, and here f of 0, we've got infinite multiplied with t, sorry, multiplied with s. So sorry, so t is the variable, you substitute infinite for t, and here you've got e to the power 0s, right? This will give us 1, this entire thing will give us 0. I mean, even if it doesn't, let's just assume that it gives us 0 and suspend our disbelief for a minute, right? And here we have already got s, the constant s, multiplied with the Laplace transform. We've got a negative f of 0, thus we can say f dash is equal to s multiplied with LF, the Laplace transform of f, minus f of 0, and we've got the desired result. Thank you. Hope you understood this question.